Hello, everyone. Good evening, and welcome to the Museum of Science. Tonight, we're honored to celebrate the 5th anniversary of the Lee and Nile Albright Annual Symposium. To enhance the museum's Hall of Human Life, Dr. and Mrs. Albright established this series of symposia to highlight cutting-edge science that would excite us about the human biology and health and inspire us to learn more about our own bodies and health. Dr. and Mrs. Albright, thank you very much for your generosity to the museum and to the adult programs. And Dr. Nile Albright will say a few words.
Welcome. This is all a special occasion for our family, and it involves every member of it, as they've had photographs going right back 5 years ago, and each year recording what we have accomplished and what we have done in the lessons of science, and what we can learn from it, and what the human brain is doing to us, and how we can improve. You're going to hear some remarkable research results from our two speakers tonight, and it's going to challenge your own thinking of what our brains are doing. So without any further delay, I want to turn it over to our moderator and to Lisa, and we hope everyone will enjoy it. There will be a question series at the end of it. Thank you all for coming, and welcome.
The human body really is a miracle. I mean, two cells come together, and from there, this body grows with all the organs, limbs, a whole nervous system, and these sensory abilities we get. But perhaps the most miraculous part of all is our brain. A relatively small organ, weighs only about 3 pounds, but one single brain has over 100 billion neurons. And those neurons make over 100 trillion connections. That's a lot of brain power. So our tonight's special guest will sort of fill us with the wonder and awe of our brains and our bodies as they tell us just how much our bodies and brains seem to sort of have superpowers without us even having to try. First, we'll hear from Dr. Rachel Herz, a world-renowned expert on scent and the psychology of smell, and how our brains influence our experience of food. Next, Dr. Joelle Salinas will talk about what seems kind of like magic, synesthesia. We'll journey into the mysterious world of mirror touch synesthesia, which is a world that very few people experience, but one that Joelle lives every day. After the two presentations, Joelle and Rachel will have a conversation, and then there will be time for questions from the audience. And we'll conclude with a book signing with both of these two scientist authors here on the stage. And we hope you'll stick around to continue the conversations. So without further ado, please join me in giving a warm welcome to Dr. Rachel Herz.
Thank you all so very much, and I'd first like to really extend a very warm thank you to the Albrights for putting this symposium together. I'm really honored to be here, and to Lisa Monrose for finding me and inviting me. I'm really delighted to be able to share some of the features that make our brain seem superhuman. And this was the task that I was given to come up with respect to our relationship to food. And I thought I would give 3 exciting facts about how our brains are really fantastic when it comes to our experience of what we eat. And the first thing I want to tell you about is how our brain is actually what makes flavor. It does not come from your mouth. Although I bet that 99% of the time, 99% of you say the word taste when actually you mean flavor. So, first, I'm going to give you just a quick overview of what the distinctions are between taste and flavor. And these are the only sensations that you actually perceive in the most strict sense from the sense of taste. Salt, sour, sweet, and bitter. And they're stimulated by chemicals in our environment that are dissolved in our mouth, in our saliva, and we get these specific experiences. Now, flavor, on the other hand, is, for example, salt plus bacon aroma, and that is what gives you bacon. Bacon taste is just salt. It is the aroma that creates it. So, for example, if you did not have the aroma, all you would taste is salt when you have those crispy strips. And this is actually a very unpleasant situation for people who've lost their sense of smell and are craving trying to get back the pleasure of food. And it's one of the reasons actually why people who lose their sense of smell over time can end up with poor nutrition and also even gaining weight, because the only pleasures they get from eating are salt, sugar, and fat. And they are desperately trying to recreate the passion that they had with eating, and it doesn't happen. So, what's going on? Well, what's going on is that when you are experiencing food, you're also breathing, as you probably know. And when you inhale, the thing is that you have food in your mouth that you're chewing and it's getting dissolved in your saliva, but the aromatic molecules that are in that food are actually traveling up from the mouth here into the nose through this passageway. And by the way, right here, this is where all the olfactory sensory neurons are, and this is where picking up the sense of smell actually takes place. And so what's happening is through the back of the mouth, this is where the smells are coming through. And this is why, for example, you may notice that when you have a bad cold, food doesn't taste right, and that's because this passageway is blocked and you're really only getting basic taste. Now, you're also getting smell this way through your nostrils, but the main action is happening over here. And it's actually an illusion that it's taking place in your mouth because it's really happening over here, because the brain is knitting together the sensations of taste, that is to say, for example, salty, with the aroma of bacon, which, by the way, is composed of dozens of different aromatic molecules. There's no one bacon smell. And putting those two together, but because it seems like it's coming from the mouth, it feels like that is where flavor is. So that's also one of the reasons why when people say, for example, they've lost their sense of taste, it's extremely difficult, as you'll see shortly, to lose your sense of taste. Most likely, however, and unfortunately, it isn't very hard to lose your sense of smell. Plus, as we all get older, just like with vision and hearing, that's another sense that tends to fade. So, but actually, it is not taste that you're losing, it is unfortunately smell. And I'm just going to give you, unfortunately, we weren't able to put this together tonight to hand out jelly beans, because I would have loved to be able to do this with you. But when you get home later, and by the way, this is a trick that works with children of all ages, so I think you'll enjoy it very much. You can do it with jelly beans. It's actually the best way to do it, or with lifesavers. What I want you to do is, in your own time, take one of these different kinds of things, and you can take a couple of different colors because you know that they're going to have different flavors, and plug your nose and put one of those into your mouth and bite down, and then you'll only taste sweet. And then when you release your nostrils, you will be overwhelmed that it is licorice or vanilla or lemon or whatever. And I actually do this in my class every year when I teach, and at the end of the semester I often say, so what was the most interesting or surprising thing you learned this year? And invariably at least one person says this. So I could just leave after the first week of class. So the other thing, by the way, that you would notice is that the jelly bean or the lifesaver will taste sweeter when you can also smell, because smell and taste create this synergy in our brain to complement each other. So I'm now going to move on to amazing superhuman brain fact 2, and that is that your brain alters your perception of calories and your metabolism. So you see this halo here, and that's because there is a phenomena called a health halo effect. And that is that when we think something is healthy, and this is just because we believe it's healthy, we tend to infer a bunch of other healthy attributes to the same thing, even when it's not true at all. So for example, we may assume if it's healthy, it has fewer calories. So here's two famous places where you can go and have a meal, and one of them has made a reputation of being healthy, that is Subway, and the other we all think of as being relatively unhealthy, even though they now have salads and so forth. And in actual fact, people who have been in studies where they have been asked to estimate the number of calories in a meal that they've just consumed from either Subway or McDonald's. By the way, everybody underestimates how many calories they've consumed. But people underestimate the Subway calories between 20 and 40% more than they do the McDonald's calories. And just so you have an idea, a Big Mac is 563 calories, but there are a bunch of 6-inch subs at Subway that are more than 570 calories easily. So they are not healthy, even if they claim to be so. But our minds believe them to be anyway. So here is another example of how we make this mistake, as it were, in perception. And this has to do with the word organic. So organic, by the way, says nothing to do with the content of the food. It has everything to do with the production. Organic is about farming and about the use of pesticides or not use of pesticides and how something is produced. It doesn't have anything to do with the content, especially not the calorie content. What I'm telling you about here is a study done with undergraduates where they were given Oreos and said they were told that either this is made with organic flour and sugar, so only the word organic is there, or conventional. And they were also shown this label, okay? On both of these cookie types, the conventional and the organic, they all had 160 calories, and 2 cookies was the serving size. So that's the nutritional content. And then they were asked to estimate how many calories were in these cookies relative to each other. And what you can see from this graph is people underestimated the organic calories in the Oreos by over 30%, even though they had just read the labels that they had the exact same number of calories. So this is a major effect in terms of how our brain literally does not want to believe when it thinks about something as being healthy. You don't want to believe that your organic potato chips have as many calories as the Frito-Lay bag does, but I'm afraid to say that that's not true. So I'm going to move on now to another really exciting thing, and this I think is even more amazing than how we kind of trick ourselves when we think about health. This has to do with something that most people would not assume you're going to be able to trick at all, and that is your metabolism. And this is a study that was done by Alia Crum when she was at Yale University. She's now at Stanford. And it is an amazing example of a placebo effect, in that how the mind is really controlling the body in a way you would never imagine. So for this study, what she did is she had people in the Yale community eat a French vanilla milkshake. And these same people consumed it at 2 different times. This vanilla milkshake actually, in reality, contained 340 calories. And they consumed the exact milkshake at both sessions, separated by a week. But in one session, they were presented with a milkshake, and it had this label: indulgence, decadence you deserve, and if you can see this, the calorie content says 620. The next time they had the milkshake, or in the opposite session, it came with this label: Sensi Shake, guilt-free satisfaction, 0% added fat, 0 added sugar, 140 calories. And what she looked at was the response to a hormone in our body that is produced by the gut called ghrelin, and ghrelin is sometimes called the hunger hormone. So when you're hungry, ghrelin goes up, and after you've eaten, ghrelin goes down. And technically, the way this should work is that the more calories you consume, the more ghrelin goes down, because your body is responding to the intake of actual calories. That's the way, if you asked a physiologist, that's sort of the technical way this should work. And now I'm going to show you what happened at this experiment. When people consumed the milkshake that had 340 calories in real life, but thought that it had 620 and was this extravagance and amazing luxury, their ghrelin levels dropped after consuming it 3 times more than when they consumed the exact same milkshake, but thought that it was only 140 calories and sensible and guilt-free and all the rest of it. What this also means is that when ghrelin levels drop, our metabolism revs up and we burn more calories, because your body thinks, oh, I've just had all this huge amount to eat, therefore I better burn it all off. So these people were burning a lot more calories than these people, and they'd actually consumed the exact same food. I mean, they're the same people, actually, they're just 2 different times. So what this is actually saying is that you should stay away from diet labels. And this is this paradox that when healthy connotations are used in food labeling, people underestimate caloric content and the physiology of food consumption is stalled. So if you can, please don't look at that label that says low fat. And in fact, actually, high fat is more satiating than low fat because fat is a very satiating macronutrient. And usually the calorie content difference is negligible. So I would say don't look at diet stuff or try to convince yourself that everything is super decadent so that you can be burning lots of calories all the time. So the next thing I'm going to tell you about is Superhuman Brain Fact 3. And this is that what you see and what you hear actually changes your ability to taste. And to start off, I'm going to tell you about how you see influences your ability to taste. And there's a famous Chinese proverb that says you eat with your eyes first. And I'm sure you've all had this experience that you see food on the plate in front of you, and it looks really beautiful. You're in a nice restaurant. You're all excited. You're ready for this really delicious meal. And most of the time, unless it's really awful, you will feel like your expectations have been met. But there's other ways that your eyes can also deceive you, not just plating and presentation. And this actually has to do, very interestingly, with the effect of shapes on our ability to taste. And this was a study that looked at whether or not round shapes versus angular shapes would influence one's ability to perceive a sugar solution that was at very low concentration. And in this study, there were 6 different concentrations of sugar. The lowest one had nothing at all, so it was just pure water, and then a little bit more sugar was added. And this one is the one I'm going to be telling you about, and it was just below the normal threshold of being able to detect that it was sweet. And the reason why the question was, would roundish shapes versus square or angular shapes have an influence, is because in life, when we see round things, they tend to go with sweet things. So cakes and cupcakes and ice cream scoops and fruits, they're all sweet. And angular things like chips and meat cuts and cheese cuts and so forth tend to be salty. So the idea was, would seeing a shape actually change the ability to detect a sugar solution? And so what people did in this study is they saw these shapes for one at a time for 5 seconds, and then they were given these different concentrations of sugar, and this is what happened. So with the round shapes at this barely just below the threshold of detection of sugar, people were able to perceive that this was sweet. But with the angular shapes, they were not. So literally just being primed with seeing a circle will make you be able to taste sweet more. And so look at circles and then don't put very much sugar in your coffee, and it'll taste really sweet. So now I'm going to tell you about how hearing changes your ability to taste. And this research started because Lufthansa in 2010 noticed something really odd on their flights. And that is that they noticed that people were ordering tomato juice as much as they were ordering beer. And the reason this was especially surprising, first of all, anyone who knows anything about fruit beverage or the beverage industry knows that fruit drinks are way preferred over vegetable drinks. And also, by the way, on these flights, the beer is free. So it's not like, oh, I have to pay for the beer, so therefore I'm going to take a juice instead. You can either get beer or juice, and people were choosing tomato juice just as much as the beer. And so they paired up Lufthansa with LSG Sky Chefs, and they're the catering company that is in most major airlines preparing your food. And they simulated an airplane cabin situation on the ground, and they found out one thing in particular that was quite interesting is that in the low cabin pressure that you're experiencing, actually your nasal passages get clogged up to a certain extent, and you don't smell as well, so flavor is reduced. So that's an interesting thing. But they also found something was going on with the sound that's in an airplane. And it turns out that being in an airplane cabin is really loud. Being in an airplane cabin is like standing 30 feet away from a jackhammer. The ambient noise is about 85 decibels, or it's like standing over your sink with the disposal running. So that's actually really loud, but we get kind of attuned to it, we habituate to it when we're in an airplane for any given length of time, so you don't really realize how much noise is happening around you. Now, here's where I'm going back to the sense of taste. Did I move myself? Okay. The sense of taste is actually innervated by 3 cranial nerves. All of our other senses only get 1 cranial nerve. And this is why it's extremely difficult to actually lose your sense of taste, because there's always some other backup. Now, one of these cranial nerves in particular is very interesting because it is also the cranial nerve that's involved in hearing. The chorda tympani is one of the cranial nerves involved in taste, and as it's leaving the tongue and going to the brain, it passes first through the middle ear. And as a function of the sound that is around, it actually causes perturbations to the chorda tympani that change our ability to detect tastes. So, research which was done at Cornell looked at how this happened and to what taste in particular. And this time they included umami. Umami is a very controversial taste or oral sensation. There's reasons why I don't consider it a basic taste, but in this particular experiment, they included it. One major reason is because it's very hard to distinguish it from salt. But in any case, in this study, people were given different solutions of salt, sour, sweet, bitter, and umami, 3 different concentrations, and they either had headphones on in which nothing was played, or they had headphones on where 85 decibels of white noise was played while they tasted these different solutions, and they were asked to rate the intensity of the solutions. And what was found, first of all, is that detection of sweet and salty went down. So you need to be looking at extra round stuff on an airplane to detect any sweet. Sour and bitter didn't change at all, which is why when you're on one of those transatlantic flights and they give you that fruit cocktail for breakfast, it tastes like just the grapefruit is just as sour and bitter as ever, in fact, more so. And interestingly enough, umami, however, went up in taste intensity with this loud sound compared to no sound at all. And the more umami was in the concentration, the stronger the sensation was with loud sound. Now, it turns out that tomatoes contain a lot of umami. And therefore, when noise levels are high, sweet and salty tastes are reduced, but umami is augmented in it, so foods rich in umami taste the best. Tomatoes, Bloody Marys, mushrooms, bacon, spinach, cheese, and bread, so you should eat pizza on airplanes. And that basically summarizes just very briefly these sort of little tidbits, a little tasting for you of some of the ways that our brain does superhuman things when it comes to food. So just a quick summary. Flavor comes from the brain, and what we believe, see, and hear alters how food tastes and the consequences of food metabolism. And understanding the myriad sensory and psychological factors that influence eating will enable us to have a happier and healthier relationship with food. And I want to thank you very much, and this is how you can contact me if you would like to. And I would now like to pass the baton over to Dr. Joelle Salinas, and we can talk more shortly. Thanks.
Hi. Woo, this is loud. First off, let me just recognize that I know that I look barely old enough to vote, let alone be a doctor. But I am proud to say that I do both. I also wanted to thank the Albrights for their contribution and for the invitation. It's amazing. So thank you so much. And just to kind of summarize a little bit of what I'll be talking about today, I'd say there's 2 big goals. One is that maybe you would learn something new and powerful about yourself today, and 2, that you stay curious. One of the things that I learned early in my career learning about the brain was this one saying that someone said, which is, all we will ever know is the state of our own nervous system. And this really struck me, because it's the idea that our brain is in this kind of dark tomb in our skull, and is really kind of where we're kind of perceiving a lot of the world. And it felt, when I first learned that, it felt a little lonely. So let me begin by sharing a little bit about kind of myself. So I was born and raised in Miami, Florida. My parents are from Nicaragua. They're immigrants. They fled during the Nicaraguan Revolution, seeking political asylum in the U.S. and they're both very loving parents, and so very, very lucky to have them. And one of the things that was a little peculiar about myself growing up was, one, I was just really immersed in the world of television, but I also had very specific things. Like when I colored the letter A, it had to be red. When I colored the letter B, it had to be light orange, and a very specific light orange. And I also connected a lot with adults, and I seemed to be very, very attuned to other people, which is unusual compared to other kids. And I was also just really fascinated with the world around me. I would spend just almost forever staring at a droplet of water. No one really knew exactly why. And it was only until my first year in medical school where I began to really learn about what was going on in my brain, but also what separated myself from other people. And I'll never forget, I was on a medical mission in India with other medical students when a friend of mine who had a background in neuroscience happened to chime into the group and say, "Did you all know there are people who can literally see sound in colors or see colors in letters? It's like they're on this acid trip all the time." And when I heard that, what I was struck with was, why would he say that? That's so boring. Everyone has that. And it was only later that night, or I confronted him and I said, you mentioned these people who can see kind of sound things. Why would you mention that? Everybody has that. And he just kind of looked at me and said, no, that's definitely not normal. And that's when I learned about this thing called synesthesia, and it kind of launched me on this journey to learn more about synesthesia and the brain, to go into neurology and be studied by neuroscientists, and to develop this deep, deep love for the brain, about learning about who we are and how we connect with one another. Full disclosure, I tell a lot of these personal stories in my book called Mirror Touch, and I'll be happy to kind of share some of those stories later on, and I'll certainly will during the talk today. And one of the reasons why I think it's important to think about the brain and our senses is that there's clearly a need today to understand who we are. There's so much suffering and pain going on in the world, and a lot of that information first comes through our senses. So if we kind of take a step back and think about kind of what we were taught growing up, which is this idea that we have 5 senses, I want to start out by saying that actually that's not 100% true. There's actually a lot more senses. We have a sense of warm and cold, we have sense of chemicals, we have sense for pain, we have a sense for vibration, we have a sense for the positioning of our body in space, we have a sense of orientation, and there are even some animals that have a sense for electromagnetic fields. So one other thing that may sound a little unusual is that when we think about our senses, we think about kind of passively receiving this information in the world outside and then kind of processing it in our brain, but actually I'll challenge that just a little bit. So if you'll see this grid here, notice that there's one tile that's A, another tile that's B, and kind of think about how those two tiles are how they look. Now, would you believe me if I told you that tile A and B are the exact same color? And that's just to show you that they're the exact same color. And the reason why I demonstrate this is that your brain is actually also making guesses about the world around you, more so than just taking in the information. So we're perceiving information, but we're also predicting information. And that prediction of the information that's going on might as well be reality to us. So you see these two shapes. One is called Kiki and one other is called Booba. Which one's called Kiki and which one's called Booba? Most people think the sharp one is Kiki and the round one is Booba, surprisingly. People also give other attributes to Kiki. They say it's nervous and clever, and that Booba is lazy and slow. And the reason why I think this is important is because all of our senses are tied to other ideas and concepts. Colors have names, and shapes have different associations to themselves, and it's all part of this big network in the brain. And if you think about how all these different concepts of sensations in the brain are connected together, and you think about how lots of different words and sounds come together in this kind of massive network. So even as you're looking at the world outside, you might see a tree, and we used to think that seeing a tree just meant that you saw the tree and that was it. But actually, what we've learned in the neuroscience is that these are just ideas that our brain is creating, and it's not just sight, but actually your brain is active in terms of touch and taste and smell and hearing, and all these things come together. Like your brain is recreating the world around it in 3D virtual reality, and this also has implications for our sense of self and who we are to other people, and it creates these big philosophical implications. But for the world around us, it's really just a blob until we are taught in a way that what a tree is. And neuroscientists are trying to figure out why these things are the way that they are. There's been, as soon as you're born, one thing that we know is that you have these 100 billion neurons in the brain. And the way that these neurons, these brain cells, connect with each other is through activity. So the more that brain cells connect with each other, the more active they are together, the stronger those connections are. And they become these big, big networks. The other thing that's seen is that not only are things that kind of fire together, wiring together, but also things that don't connect very much, they begin to lose some of that connectivity. And in seeing that connectivity live is pretty amazing. So this is a zebrafish having its neurons, its brain cells shown. So you're literally seeing brain activity going on. You can see how these different brain cells are actually firing and connecting with each other in large networks. And we're now able to see how even these zebrafish have their brains active as we move around in terms of behavior. So the technology around being able to see brain activity is slowly advancing, but it's just amazing to see how far it's come along. And another layer of complexity is that it's not just neurons. Actually, all the other cells that support those neurons are actually involved in how active those brain cells are. So if you think that your neuron is already complex, like the processing power of a laptop, now imagine that times 100 billion times. So the brain is just amazing. Which brings me back to synesthesia. So to me, when I see this word, this is the colors that are laid over on top of it. S is light orange, Y is yellow, N is light brown, E is blue, etc. And this, the word synesthesia comes from two roots. One, syn, meaning together, and aesthesia, meaning sensation, so bringing sensations together. And someone who has synesthesia might experience the world kind of like this art by artist Andy Thomas. Where there's sound that also evokes a very rich visual experience. And if you were to ask a scientist, what is synesthesia, they might give you a definition like this. A synesthesia is this perceptual phenomenon when a sensory stimulus presented in one modality spontaneously evokes a sensation in an unrelated modality. Or this. The senses are combined. They all blend together. And if you ask kind of what are some of the qualities of synesthesia, they might tell you that it's developed at an early age, it remains relatively stable over time, it's usually different from person to person, and it tends to run in families. Or this, in quite simple emoji speak. So there's another component of it that relates to attention. So let's take a look at the word cat. So when I see this, the letter C has a color black on top of it, the letter A is also red, and the letter T is red-orange. But if I see this, when I focus on the C and the T, the middle letter turns red, like the letter A. When I focus on the T and the E, the middle symbol turns into this orange color, like H. So attention plays a big role in this. It also plays a role in some other kind of quirky ways. So someone with synesthesia could see this, and you say, what do you see here? They might actually see that there's actually a triangle shape faster than people who don't have synesthesia because the color of the number 2 for them is a different color than the number 5. Someone with synesthesia might also have the blending of the sense of sight and sound, as I mentioned. So this is coming from an artist, Carrie Furman. When she hears animal sounds, these are the different shapes that she experiences. There's also motion and sound. So when I see this, what I'm hearing in my brain is whoo, whoo, whoo. Also, when I see numbers, they have specific colors tied to them, but also each of those numbers has very specific personalities and characteristics tied to them. Yeah. It also works in reverse, where when I meet people, there's also colors and numbers tied to them, kind of like this Magritte sketch. And if you look at brain scans of people with synesthesia, one of the things you see is that in the top left corner, you'll see that the color and face recognition parts of the brain tend to be a lot more active together, and these areas also seem to have kind of connections that are thicker compared to other people. And one of the ways that this connectivity kind of presented itself, I was being studied by one neuroscientist named V.S. Ramachandran at University of San Diego. And he drew 3 number 2s, and he asked me, what is the color of this 2? And I said, it's like a fuchsia red. Everybody knows that. And he began to rotate it slowly and asked me, what color is it? So he rotated it, and I said, yeah, it's still red. Again, it's still red. And then suddenly it turned brown. I thought to myself, well, that's weird. Why would it turn brown? And then I realized, oh, they're ends now. The color changed before I even knew that the shape had changed. And if you look at studies of what's called MEG, or magnetic encephalography, you can actually see that the line that's blue is people with synesthesia, that the color parts of the brain become much more active compared to people who don't have synesthesia, and it becomes active faster than when you actually see the numbers. So it's kind of a quick reaction that's going on. Kind of a psychologist kind of perspective on this might also be this idea of cognitive inhibitions. So there's kind of the conscious mind that you're aware of and the unconscious mind. And in the unconscious, things that are going on below the hood, there's metaphors and perceptions and memories and images and thoughts and all these things. And there's this filter in between that and the conscious mind where a couple of things that are really only relevant are in your level of attention. But when you have cognitive disinhibition, that filter becomes more porous. And a lot of these concepts seem to almost kind of like seep through. And that can happen when people become really sleepy and other things where their ideas tend to blend together. One psychologist named Shelley Carson thinks of creative genius with similar terms. If you think about this Venn diagram of things that support creativity and things that support kind of psychopathology or disorders, there's this middle sliver of the Venn diagram where you're more likely to find in people who have creative genius. And 2 of those I think are really interesting. One is hyperconnectivity, kind of like in synesthesia, and another one is what's called low latent inhibition. In other words, that filter is more porous in some of these people. And some people may actually relate with experiences like these, where you have the sounds and the instruments that have this visual experience tied to it. And there's something very specific about these shapes. Some researchers call them Clouverian forms. Essentially, they seem to be very common amongst a lot of people with synesthesia, but there's also another element that you find that's interesting, is that some people will experience these shapes when they use particular substances. Some of you may be familiar with the substance. It's LSD. Some people who are using LSD may actually experience some of these same shapes that people with synesthesia do. So kind of some basic facts is that about 4% of the general population has some form of synesthesia. It's actually found more often in people who are on the autistic spectrum, but especially people who are savants, who have these kind of very prodigious abilities within the autistic spectrum. More often, it enhances someone's cognitive functions than it impairs, and there's many, many sensory combinations, so many that if you were to tally them up, you'd have well over 80 different combinations. From my perspective, I think the senses are already blending together, so kind of tallying them up doesn't really help much because it's kind of like mashed potatoes in the brain. And there's this one interesting combination here that came up in a lecture once, where a neuroscientist was kind of giving a lecture about synesthesia and asked if anybody had synesthesia in the audience, and a student came up afterwards and said, I don't know if this is synesthesia, but when I see people being touched, I feel touch on my body. That ended up being studied and ended up being the very first case of someone with what's called mirror touch synesthesia, a variant in synesthesia, one of the many types of synesthesia. And that was back in 2010. It was when I was just beginning medical school. So some questions about mirror touch is, how does this mirror touch experience compare to everyone else? So some of you may be familiar with this term, mirror neurons. And actually, mirror neurons is a little bit more outdated, and the term that's being used more or less now is mirror systems or mirror networks. And the idea is when you are seeing someone, when a monkey's seeing someone eating or grabbing an object, the same parts of the brain that are involved in grabbing that object are active as well. And this mirror network is a part of many, many networks in the brain that are involved in social cognition. Another element is how we perceive pain. So if you define pain, it's actually this unpleasant sensory and emotional experience associated with actual potential tissue damage or described in such touch damage. And so you have what's called nociceptive pain, or the typical experience of pain that people feel when they have their foot stepped on. There's psychological and mental pain, and then there's empathic or empathetic pain just from watching others. There's many, many dimensions of pain, and if you were to kind of summarize them kind of more discreetly, you could talk about kind of sensory pain, kind of the sensation on the body, emotional or affective pain, and then there's cognitive elements of it. In terms of the emotional elements of it, what's really fascinating is that areas of the brain that are active when you're experiencing pain are very much the same parts of the brain that are involved in a lot of emotion processing. And when we see other people, this is all of us, when we see other people experiencing pain or being touched, our brain is actually active similarly, as if our brain is trying to do this kind of 3D virtual reality type simulation of the other person's experience. And there's a lot of overlap between this kind of empathetic part of the brain, or these empathetic areas, and the pain experiences in the brain. These same mirror systems are linked to how we perceive each other, to how we process the behavior of others, and how we act. And there's been many studies that look at these areas that seem to be similarly active with the mirror system. The mirror system is also really active throughout our lifespan. So there's this test called the Rouge test, which I think is just really cute. So if you put a little bit of rouge on the forehead of a baby and you have a mirror near them, they'll look at the mirror and they kind of look around. Sometimes they'll look behind the mirror, wondering who's behind that. But after about 18 months, something really interesting emerges, where when they look in the mirror, they actually notice that red dot and realize that the red dot's on their head. And this relates to a lot of this mirror system kind of beginning to develop, which is involved in a perception of who we are and how we are different from other people around us. And you can begin to see some of this mirror network activity as early as about 4 months old. And as we get much, much older, you begin to see changes in how we perceive the world around us. So, for example, our ability to perceive differences between random objects may remain the same, but our ability to perceive differences in facial expressions and what we think those facial expressions mean will actually decrease with age. And from person to person, regardless of age, you can be lots of really big differences in that. So if we think about empathy, which is this process of thinking and feeling kind of the experience of another person, there's kind of a spectrum where we have people who maybe have really low empathy or very high empathy, and it depends on the context and who you're looking at. And there's a lot of factors that are involved, but some of us tend to live in this higher range, and then you have people with mirror touch who are in this very, very extreme end. And another question about mirror touch might be, is it real? And some of the studies that are used to kind of find out whether somebody has mirror touch or not is what's called the visual tactile stoop, where people just seeing somebody being touched can be really confusing for people who have mirror touch, where they begin to lose track of who's being touched or whether they're being touched actually, where they have like these electrodes in their face that are shocking them as they're seeing somebody else. It's also really hard for them to follow commands when they're seeing somebody else in front of them doing things with their hands. If you say lift your index finger and the person in front of them is lifting their middle finger, they'll have a harder time. And why is this going on? There's differences in brain structure and function in our genetics. So seeing this person here, for most people, if you see them being touched on the right side of their face, your brain is recreating that experience as if you're being touched on the left side, but you're unaware of it. But in people with mirror touch, that experience is much more vivid. And you see that in the brain of people with mirror touch, these brain areas in the mirror system are not just thicker, but they're more active, and parts of the brain that are involved in distinguishing between yourself and others are thinner and less active altogether. And more recently, there's been some studies showing that there's big genetic differences in people who have synesthesia, and specifically the genetics, the genes that are involved, they're genes that are involved in how our brain cells actually reach out and connect with each other and how it's developed, which makes a lot of sense as it relates to connectivity. And so how does this knowledge really apply to everyone? And I think one is that it gives us insights about our social perception, our behavior, and our relationships, but these insights can also be harnessed toward improving our health, our well-being, and also our society. So some of you may be familiar with this thing called the rubber hand illusion. What I think is really fascinating is if you kind of set somebody up to have kind of like a dummy hand in front of them with a divider, and you actually have the real hand on the other side of the divider, if you stroke their hand with a brush while they're also watching the dummy hand being stroked, that mirror system kind of kicks in. They begin to see that dummy hand as a part of their body. And what ends up happening is that they actually can experience pain as if it was happening to them. And it also, you can see it with these kind of really creepy doll experiments, where if you have somebody set up with a camera on their head, and they're seeing kind of in virtual reality a doll being stroked, and you do it enough times, they begin to kind of blend in with that, and you do something really mean, and you bring in a knife, they can actually feel as if it's about to happen to them. And you also see this in everybody when they see people in pain in movies and things like that. They experience a lot more emotional distress, and they have a lot of the same physiologic changes as it relates to that. And you can kind of train the body to either kind of loop back into that mirror system even more or less over time. And that can be across people who don't look like you. So doing a task like this increases kind of positive thoughts towards somebody that doesn't look like you. There's virtual reality experiments that are used where if you just spend some time in the skin of another person, you can have more positive feeling towards them. And they can actually be seen as well, similar to that creepy doll experiment, where if you have a VR system set up on somebody else and you see kind of movements as if they were your own, you create this illusion of having your body swap. So almost literally being in the shoes of another person. Also, just simply meditation. People who are able to meditate on the experience of other people, they have very significant brain changes and kind of what areas of the brain that are tied to compassion and altruism and empathy. That may have big implications for people's perception of suffering, but also can be applied in medical training as well. I think this is still an area that's being studied, and I think it'd be really interesting to see over the next couple of decades where that goes. In the future, we'll learn a lot more about just general mechanisms, kind of overlaps between different types of experiences of empathy and what the causes are, and we'll find applications and treatments for that. So kind of going back to this idea of all we will ever know is the state of our own nervous system, I think one of the things that gives me hope is that we're learning is that the more we learn about ourselves, the more we learn about what we mean to one each other. How understanding ourselves really is dependent on how we understand each other. And I'm reminded of this artist, Lucia Papa, this piece of performance art is called The Divisor, how we're all very, very connected, much more than we actually realize. And I hope that one day we'll be able to break through that box and connect each other, kind of like these two little identical twin babies who see each other with a sense of curiosity and generosity and novelty. Thank you. And now I'd like to invite Dr. Rachel Herz back up for a conversation.
That was a brilliant talk.
Thank you. I loved yours.
Well, thank you. So, but I have to tell the audience something about you they may not know, which is that you have mirror touch, and especially with the experience of pain. Do you want to tell us a little bit about that?
Yes. So, I have synesthesia in general, and I have lots of different forms of it, and one of them is this mirror touch experience. And when I first learned about it was actually when I was in San Diego, and one of the grad students asked me, do you have mirror touch? And in my mind, I was like, oh, I know about these mirror systems. Everyone has that. What do you mean? And he said, well, when I do this, what do you feel? And I said, oh, I feel like there's someone touching the left side of my face. And he looks at me and says, yeah, that's not normal. Yet again, I assume that the whole world is experiencing it the way that I did. And, for me being a doctor, seeing patients and having mirror touch, what that means is that I get to have maybe a deeper connection with my patients in a way that gets to help me provide better care for my patients a little bit, or at least they feel like their doctor is just very connected with them.
Great. That's the definition of an empathic doctor.
Well, one of the questions I had for you was just, you have so much awareness of all this knowledge about the senses, about smell and flavor. What's the world like? Like, when you go to a restaurant, like, how do you eat?
I just order pizza because I love umami. And I make sure everything looks round when I have dessert. No, so interestingly, I am a super taster, by the way, and that's just something which is actually genetic.
Ooh.
So that's something that I can't alter, and it doesn't have anything to do with my research. That has some upsides, it has some downsides. It means that everything in the world of my experience of food is more intense. But I think that the research I did for my most recent book, which actually I did learn things that I didn't already know, quite a lot of things I didn't already know, it made me realize sort of one of the major messages that I want the book to really impart to other people, which is if you just sort of take a minute or a moment to realize how many things are influencing us constantly when it comes to our experience with food, whether it's sensory or psychological, it's emotional, it's social, it's the environment we're in, and how all these things are interacting and actually altering reality.
Yeah.
That is something to take stock of and then sort of try to piece apart and go, am I really enjoying this? How much am I enjoying it? Is it really worth continuing to eat? And so that's really where I've tried to impose a little bit of that knowledge onto myself.
That's just so cool. It's the idea that the brain is like this motherboard of reality, and then you can kind of like hack it a little. I'm totally going to do that jelly bean experiment when I get home.
Yeah, that's actually the really amazing part of all this is that we can do so many different body hacks when it comes to our own experience for everything. And food is just one domain, I think. But it's really interesting to think about how pain and also compassion and our relationship with other human beings can also really be influenced by body or brain hacks. But it would be nice if there could be a way without having contraptions like mirrors and having to set up to do this a little bit more so that we could actually be a little kinder all the time. Do you have any ideas?
Yeah, it's one of the things that's been seen in research around kind of this mirroring system and kind of what we call, shared pain or vicarious pain, is that when you are observing someone who you relate with a lot, so like seeing a video of yourself being touched or in pain, or seeing a family member or your spouse, those brain areas become much, much more active than if you were seeing someone who does not look like you or who you do not relate with. And I think what's really powerful about that is knowing that, one, there is this bias, right? There's this bias about people that we relate with that's going on below the surface, even when we think that we're being very, very open-minded. But also that can change, right? The more you begin to see other people, especially strangers, you begin to see them as someone like you, the more you relate with them, the more you can kind of increase the volume in that system. So you might actually be slightly more compassionate toward people that you wouldn't have beforehand. And even, there's this fear that some people have about, being accurate, in kind of imagining what the experience of somebody else is. And it's less about the accuracy of what that somebody else is going through, and it's a lot more about how vivid you allow that experience to be in yourself that is more likely to drive you to do something kind towards somebody else.
Well, that's really interesting because it also relates to our experience with food. So the more attention you pay to sniffing, for example, the more you will actually smell. And the more engaged you are with eating, the more you will actually perceive. And in fact, doing little rituals, like even something like, as long as it's a ritual and not some random behaviors, but let's say you cut something in half this way, then you move it over to the plate on this side, then you wrap the table 3 times, and then you eat that piece of food, you will actually perceive that food as having more flavor, as being more satisfying, as being more valuable than if you just sort of ate it. And certainly then if you just did some random things. And so it's sort of similar. The more engaged we are, and literally the more mindful we are, the more we get out of experience and the more we can relate to what's going on around
Yeah,
us.
and I love that you mentioned that term mindful, right? Because we hear it so much,
Yeah.
right? And it almost feels kind of like icky to hear it now.
Yeah, I don't like it either.
Yeah, but
That's why I say literally.
which is why, like, I think the researchers who can look at mindfulness and see it for its like the mechanics of it can still appreciate that there's a lot to be learned from there. And a lot of it is like attention and relates to the brain. So when you hear mindfulness, to not immediately like turn your brain off metaphorically,
Yeah.
but to like consider kind of the value that comes with it.
Yeah, well, it's also sort of like, in a way, the opposite of distraction. So, for instance, one of the worst things you can do when it comes to overeating is sit in front of the television because, first of all, your mind is not at all on the food. It's completely in another space. And you're also, so you're not taking any attention to what you're actually consuming. So you're not getting as much flavor or satisfaction or satiation. And nor are you even feeling your body feeling full or feeling like you've had enough. So paying attention and being aware is really the thing to do, because we need to sort of savor the moment, savor the flavor, savor the experience, because it's all so short.
Yeah, it's so short. And it's similar
So-
when I think about kind of the empathetic experience, right? There are plenty of people who say that sometimes it's too much, right? They see things and they feel the distress and they have to turn away. And then there's people who don't really feel as much. And I think for the people who feel that there's like too much, right? There's very real risk of developing what some people call empathic burnout or just burnout in general. And that can be problematic if your ability to care for other people relies on kind of making that connection with others. And that ability to draw your attention not just in the experience of the other person, but back into your own body, may actually be something that drives you a little bit further from that high empathy state to a point where you can actually just take a deep breath and help somebody without feeling that feeling of distress.
Yeah, sort of you're titrating the level of attention that you're paying to
Right.
something. So I think that's really a good point too. I mean, I think in the case of the empathic pain and the empathic distress, it's
Yeah.
definitely something one might want to try to do. But I think in the experience of food and in sensory domains of, let's say, smelling the flowers and the trees and so forth, I think that you can't have enough attention because most of the time we're not giving it anything at
Yeah.
all. So
Yeah. One of the things that I was thinking about as I was seeing your presentation, I was just really curious to hear, at what point in your life did you just fall in love with the brain? Because you could tell that you just like love the brain and to tinker with it.
ever since I knew I had one. No, well, I mean, I just, to use your term, have always been extremely curious. And I've also always been extremely sensory. Like my mother used to yell at me, "Stop squeezing the bread." Like I'd always be touching and sniffing and, kind of feeling up food. And so I think I've always been really sort of in the sensory world and in the world of the mind. And actually how I got into this area in the first place was my undergraduate degree was in biology, and then even my master's was in sort of evolutionary biology. And then I decided I really wanted to work with humans. And I saw that studying the sense of smell was the way of marrying the world of biology with the world of psychology. And then that sort of bloomed into studying taste and emotion and memory and food.
That's beautiful. How would you recommend, if someone in the audience is interested in kind of becoming a neuroscientist or something, like, what would you recommend they do?
Well, I think it's so much harder now than when I was a kid. I mean, in terms of being able to get into schools, in terms of the different kinds of competition and everything else. I think though that the more true to yourself that you are. I mean, some of the things I learned along the way. I mean, I like I said, was in biology originally. That's what my father wanted me to stay in biology. I mean, and so how much is it true to you versus true to somebody else who wants you to be what you are, something else. So I think finding out what is your true self, and then if you have a passion, really just actualizing it is the best thing that you can do, and find a passion. So whether it's neuroscience or anything else.
That's lovely.
So one of the things I also wanted to ask you with respect to your experience with the synesthesia is how do you control your own experience with your own patients? Or does it ever get to be too much for you?
Yeah, it could sometimes be too much. And I think, especially early in my training, it was pretty intense because I was seeing a lot of new experiences that are like right there happening in front of me. And I think I'll never forget the first time I saw someone die. I remember I was in my third year of medical school, And I was just sitting kind of in the workroom with one of the attending doctors, supervising doctors, and it was my first time on the medicine ward. And a code blue alarm goes off, which means someone's in a cardiac arrest, means that their heart stopped. And it just happened to be around the corner, so we run out of the room, and we go into this waiting room, and there's this person just lying on the ground getting chest compressions. And as I'm looking at him, I feel like my back is on the linoleum floor. I feel as though there's chest compressions being done on my own chest. As he has a breathing tube put down his throat, I feel like there's a sharp object going down the back of my throat. And once he's declared dead, I feel like I've just lost all sensation and almost have to will myself to breathe. And it was so distressing, and I had to actually leave and go to the bathroom, and I just threw up. And I had to wash my face and look at myself in the mirror and just remind myself, this is my body. I haven't died. This is who I am. And it was at that moment where I realized that I could not have such a severe reaction if I was going to take care of patients. And then I needed to figure something out to make it work. And rather than running away from those experiences, I ran toward them. I exposed myself to as many intense experiences as I could, because the more I experienced them, the more I'd be able to predict what would be happening next, and the more accustomed I'd get to it. And eventually, it got to a place where it wouldn't be as overwhelming, or I'd learn little tricks for myself. So in the setting of an emergency where high empathy is not super helpful, where you need to go through an algorithm, I might focus on the sensation of my toes in my socks, or my tongue in my mouth. Or I might look at a sleeve or a collar, something just enough to kind of ground myself again to be able to kind of move through that. But at the same time, that mirror touch experience has been helpful clinically, where I was consulted to see this patient not that long ago who had cerebral palsy, and because of it, she's not able to communicate. And they asked me to come see her because she woke up one morning and was just really combative. She was kicking at her nurses and screaming, and they basically wanted me to just come there and make a recommendation about a sedating medication. But when I walked into the room and saw her, I had the usual experience I do, which is the feeling of kind of sweaty hair on my forehead, seeing the sweaty hair on her forehead, seeing her kind of move her hands against the railing. I felt like I was moving my hands against the railing, but there was this added kind of subtle sensation of rapid chest rising that was out of sync with my own breath, that made me decide to take a risk and trust this feeling. And we ended up finding out that she wasn't just angry or agitated because, but she ended up having blood clots in her lungs. Wow. And it's something I don't think we would have caught as early as we did if it hadn't been for that mirror touch experience.
Yeah. Wow. That's pretty amazing.
Yeah. Well, I think I think this is a good time to open up to questions. So there'll be people wandering with mics. So if you have questions, raise your hand, and we'll do our best to answer.
First question on your left.
Hi, thank you for a very interesting talk, both of you. I was wondering if there's been any research in the difference with synesthesia across languages. For example, if someone used the Cyrillic alphabet versus the English alphabet.
Yeah, there's been really interesting work looking at Mandarin and English, and what you see is that in people who are kind of native born and learn the language, they have similar patterns as we see in someone like for example, the English alphabet or the Arabic alphabet. You see a single color for a symbol. But if you are just beginning to learn the language, that's much patchier. It's kind of the little kind of symbols or little components of it have their own individual colors. But you do see similar things. And one of the things that's really cool, so one of the things that I didn't mention was everybody is born with synesthesia in a way that as our brain is kind of maturing, we're cutting a lot of excess connections. So up until about age 2, babies have these really strong connections between vision and sound and other things like that, and we kind of lose it over time. But the people who have synesthesia, there seems to have kind of a difference in how we prune those connections and how active the brain is, which is one of the reasons why it's probably so highly related with autistic spectrum.
Great. You have your next question in the front to the right. Hi, my name is Heather, and I'm from Miami, Florida as well. I just moved here.
305.
Yes. So a few years back, there was a heated debate on social media on the color of a dress, whether it was gold or white, or I think it was blue and white. So what's your take on that?
Yeah, so that's I think that really I think it's just I love those experiences because it just helps to remind us that two people can see the exact same thing and perceive completely different realities. And one of the things that researchers have had a chance to look at this and try to figure out like why that might be, and a strong component of that is actually expectations and past experiences. And so people who are more likely to think that the room is being lit by yellow light or imagining a blue dress, and people that imagine that the room is being lit by a bluish light, they're seeing a white dress. And you also see some of these differences in people who are kind of like more like early birds and people who are like night owls that might relate to some of that. So that there's that prediction process that kind of factors into it. Same thing with the Laurel and Yanni experience people had. So some of these things are really tied to past experiences and what you expect. Even just like patterns, like what seemingly look like random patterns, if you're primed about it, you'll begin to see things in this random pattern. So I think the past experiences and difference of perspectives really, really tie into it. But yeah, I think it's blue.
I do too.
Yeah.
Next question in the
Oh, wait, actually, and the physical dress was blue. They actually went and like the people who took the original picture, they shared that it was there. You can buy this dress online, but it is in fact a blue dress.
Okay.
Doesn't make it wrong to see something else.
Next question to your left.
Hello. I had a similar question about the languages and synesthesia. So I didn't know about synesthesia back then, but when I was younger, I thought I had a similar effect when I was hearing words. I had colors for the words, but this was in my native language. Then when I moved here and started talking only in English and thinking in English, this sort of disappeared. But now I think I have a different form of synesthesia. So is it possible to lose one kind of form and have another one appear, or like have different experiences like that?
Yeah.
Or
So the question about, is it possible to kind of lose or have the synesthesia change? I think it's possible. I think in the way that synesthesia is studied, one of the things they look at is that the connections remain relatively consistent over time, but your brain is not like this like static brick like for the whole of your life. So these other associations that can happen that may change or modify some of those moments. I mean, this is actually something that you may want to comment on because we were talking about before, kind of associative learning before.
Yeah, so one of the ideas behind seeing those round shapes and sweet has to do, or the square shapes and salty has to do with the same basic underlying principles as what might be going on in synesthesia, in that we have these associations that we've learned through our experience with the world where certain things go together. And as a function of this past experience, which is in a sense arbitrary. I mean, people who are Western experienced with media and the world around them have basically the same things, but there have been tests in other cultures where they aren't exposed to the same kind of sort of marketing and media and the same sorts of even foods, and they don't have those same responses. So I would say this has to do sort of everybody's version of synesthesia having to do with the associations we've learned, and then they become sort of automatically primed and they can influence each other, so that you can sort of trigger sensation in another perception, like you can trigger sweet taste by seeing something round, but not if you haven't had the experience of round cupcakes and ice creams and things like that.
Yeah, a lot of that kind of like almost like bleeds through. We see it like in language and some things like, for example, like why do we say that we have or like a sharp cheddar? Like why is cheddar sharp? Does it cut you?
Right.
Or like
right.
why is a tie loud?
Great. Next question right here in the center.
Hi. I have a question for you, if that's okay. First, I have a comment. The
tomato juice is for real. I never like tomato juice, only when I'm on the plane. And I thought it was just me, and a couple of weeks ago I was sitting with some friends, and the friend just brought that up. It's funny, only when I'm on plane I feel like tomato juice. So that is for real. I have a question. Those 4 tastes that you hear, I always wonder what this meat is in. What is it in salty category? It is.
Yeah, so salt. So one of the other definitions having to do with basic taste is that it's a representative of a macronutrient. And so salt tends to be representative of protein. So meats tend to be that. But also to a certain extent, umami is related to protein, but not necessarily, because tomatoes, bread, mushrooms, they're all very high in umami and they're not proteinaceous at all. In fact, one of the reasons I think that the portobello mushroom is served as the meat alternative is because it's so high in umami, even though it's actually not protein. But so there are these kind of sort of incorrect associations in a certain sense, but salt really is associated to meat protein in a kind of a outside world to macronutrient connection. And that's one of the reasons why we also innately like salt, because we need to consume that as a source of energy. We also innately like sweet because it's carbohydrates, it's the easiest energy that we can find, and fat is also extremely important macronutrient for every aspect of our body. It's also actually an analgesic, it releases endorphins, so, and it's, like I said, sort of calorie for calorie, the best you can find. This is, of course, we evolved in a landscape where a good calorie was hard to find. So nowadays, there are too many good calories around, so we need to not find them as easily. But we're actually really are programmed to want these things because they represent real nutrition in terms of the outside world and our survival.
Next
And
question.
then my other question was, I'm sorry, I said I have 2 questions. Does synesthesia, do you feel like it helped you learning as you grew up as a child? Was that helpful in learning and studying throughout school, high school, middle school, whatever, or did it make it easier or harder?
In some regards, it made it a little challenging. So, for example, arithmetic. I'm the worst at arithmetic. And part of the reason is when I see 2 plus 2, like it doesn't automatically, I don't register 4. Like 2 is this red, fierce, feminine number, and another fierce, feminine number is a crowd of fierce, feminine numbers. It just doesn't work.
You're being attacked by 2.
Yeah, exactly. Or seeing like an Excel spreadsheet is like a crowd. So it took me a little bit of time to actually like learn arithmetic, and it only made sense like later that like, oh yeah, other people weren't seeing it that way. But it was also really helpful in some regards. Synesthesia typically have higher scores on tests of memory, and part of that reason may be that they have more hooks in their brain to kind of tie that information to. They also tend to score higher on tests of creative thinking. So like if you were to kind of ask somebody how many different ways can you use a brick, for example, they tend to generate a lot more ideas. So there's these really interesting ways that synesthesia can be really helpful, and there's even if you don't think you have synesthesia, you probably know somebody who does. It's just so common. I think it's an important thing to be aware of in terms of how people learn differently and experience differently. I mean, there's even celebrities who have synesthesia, like Billy Joel, Tori Amos, Lorde, Lady Gaga, Pharrell. Like all these people have synesthesia, and you see it a lot in artists and musicians. And you might argue if it hadn't been for the kind of the weird kind of programming of their brain, they might not be able to come up with really fascinating sounds or words or links that just really are provocative for us.
Next question to your left.
So I wanted to follow up on what you mentioned about the super taster concept.
Mm-hmm.
As someone who's never had a sense of smell, I've always argued to people but my taste is probably stronger than yours because that's all I've ever had. And it was interesting to understand now the difference between taste and flavor. So in one sense, I am correct that I can taste, but I was wondering, is it possible that my taste abilities have evolved stronger just because I never had that extra element of smell?
So that's a really interesting question. So the idea of super taster is actually genetic, and you were born with it irrespective of any of your other sensory faculties. And so you can either be a super taster as a function of the alleles you have at a certain spot on chromosome 7, or you're a taster, which is you have one copy of each, or you're a non-taster, which is you have 2 copies of a different kind. And it just has to do with the intensity with which you perceive taste. Bitter in particular, if you're a super taster, is really awful in general. And hot stuff is much hotter and so forth. But I would say that from the attentional perspective, when you don't have another sense, often it is that other senses become more vivid. And so, for example, people who are blind often say they can perceive food better, but they're not actually necessarily perceiving food any better from their sensory perspective of smell and taste, but they're paying much more attention to it. So in your case, I would say that your attentional direction towards food is so involved in taste. And I don't know if you also, let's say, for example, pay a lot of attention to texture, so liking crunchy or creamy, or liking combinations of those kinds of things, or hot and cold, and sort of mixing food from a variety of other sensory aspects rather than smell. I would say you're probably much more in tune with it than someone who can smell as well, which is positive too. So
great.
Good.
Next question right here in the front.
This goes back a number of years, and it was a California newspaper, but there was a doctor who had a column, and I don't remember what the question was, but the answer was that artificial sweeteners triggered a release of insulin. And I said to myself, that's very odd, because I thought basically one of the ideas was indeed with artificial sweeteners, diabetics and all that sort of thing. Was that true, and is it mental, or how does that work?
So that's true, and I'm really glad you said that, because artificial sweeteners are really bad. So those non-nutritive sweeteners are worse for you, whether you're diabetic or not, than real sugar. So first of all, you're absolutely right. So so the taste of sweet triggers the release of insulin because of the brain. And your body evolved in the real world of sweet being associated to calories. But now that they're non-nutritive sweeteners, the brain still triggers a response that releases insulin, even though there are no calories there. And so what happens is people who consume a lot of artificial sweeteners get this chronic release of insulin, and that is actually the precursor to developing metabolic syndrome and then diabetes. And the worst thing is that then when they have real calories, so like a Diet Coke and a Big Mac, that's really bad, because your insulin levels are already chronically high. You get the real calories and your body doesn't respond to them, so it stores the fat, doesn't use the fat, and the sugar stays in your blood much longer, and it ends up also being one of the reasons which leads to these really bad situations. So realizing, of course, that people who are diabetic should stay away from sweetness, but a little bit of real sugar would be better than the artificial sweetener, because your brain is just continuing to respond as if it were real, even though the sugar isn't, quote unquote, in your bloodstream in the same way. So thank you for that.
Next question in the center section.
Oftentimes people use the word spicy to describe a flavor. And spicy means so different things to different people. How would you describe spicy?
So that's a brilliant question, and I think partly it relates to sort of the idea of the synesthesia of language. So spicy, bold or bright, and those kinds of words. But spicy, for me, is the sort of piquant, like hot, peppery aspect of food, which is triggered by often capsaicin. That's the main sort of compound that's in hot peppers. It can also be triggered by something called zingarone, which is the chemical that's in horseradish or wasabi, and that it actually doesn't trigger either taste or smell. It's actually triggering a different system called the trigeminal system, which is the sort of feeling and pain system throughout the face. So it's what also when you're smelling menthol and you feel cooling, or it's to do with like the peppers in your mouth, and it's even what gives you the feeling of migraine pain. So it's sort of this branched system of sensation that's in the mouth, the nose, and the face, and that's triggered by certain compounds like I just mentioned. But so for me, spicy would be the hot, especially sensation coming from certain compounds that we use in cooking, and especially the hot pepper category.
Next question here in the center.
Hi, I ran a creativity workshop for artists, and trying to get them to focus on other senses, I blindfolded them and then had them feed each other. And it was partly a trust thing and partly a sensory thing. if they couldn't see what they were eating, they often couldn't place what they were eating. And then if someone told them they were eating something completely different, they could be convinced that they were eating it. And that was weird.
Yes, so that is so true. That is absolutely so true, because we use vision as such a strong sort of determinant of our perception. And another place where this comes in, all the time, for example, in the real world, is when, for instance, the fruit beverage company has their purple drink that is colored purple, but they actually forgot to put any sort of grape juice in it, and it's really apple juice, but just happens to have purple food coloring in it.
Yeah.
Nobody ever calls to complain to say, you just gave me apple juice and this isn't real grape juice, because we use our eyes to determine what we are experiencing when it comes to flavor, more so than anything else, mainly because from the point of view of food in particular, smells are invisible. We can't see them, so we use expectation, we use color, we use language, and unless it's really, really like opposite to what you think you should be having. So if it was onion and you saw it was grape colored, you'd be like, okay, there's something wrong here.
Yeah.
But if it's within any kind of realm of believability, then people go with what they see. And another thing that's really interesting with the blindfolds, often people, if they're blindfolded, are very cautious about eating because they don't know what it is, and they're often like, I don't want to go there because it could be scary.
And my question was really about the marketing applications of it. And another observation I had in myself was Butterfinger came out with those Butterfinger like peanut butter cup things, and they made the little crinkle shape of the whole thing, but they didn't put the paper on it. And I was like, oh my God, I like Reese's peanut butter cups so much more. And I think it is just that simple focus of peeling it off, and I have to wait to eat it. And so I'm wondering if, you could make, I'm sure you're fine, but all the marketing applications of what you know to.
Yeah, no, there's a lot about. Okay, I'm going to leave now and just become a billionaire. But you're absolutely right, and not me, but marketing companies or food companies do use a lot of that, and some other really kind of interesting things, like when you perceive like kind of a granulated sort of rough surface on things, it makes people think that something is sour, like those lemon pastilles you had as a kid. So just feeling certain things in our mouth, we're automatically triggered. And hearing sounds in our mouth when we chew. So we think if we can hear loud crunching in our mouth, that it's a fresher potato chip than if the sound is muted. If we hear a pop coming off the canister, like of the Pringles, we actually don't like that nearly as much as the rip of a bag, and it seems like it's fresher. So there's tons of stuff like that I think other people are already making money on.
Great.
Thank you.
So we'll have our final question right here in the center.
Hi. This actually follows up on the question that was just asked. So has the diet industry gotten a hold of you? Have you been consulted or talked to by
No, do you know
Weight
anyone?
Watchers? Because it seems like you've got such rich things to offer.
Well, I actually sent my book to someone at Weight Watchers and said, could I be of help? And they said, they finally got back to me and said, well, we think that the mindfulness approach could be useful for our program, but I thought, no, there's so much more. But if anyone knows anyone that they'd like to recommend me to, very happy. But thank you for that.
Thank you guys so much. Super tasters, super feelers. Our eyes perceiving what we eat. It's a fascinating brain that we have and body. I think we should all use our eyes to read their books and learn even more. If you'd like to learn more about what we do for adults here at the Museum of Science, please get on our mailing list. And otherwise, we hope to see you around again another time. Thanks for coming.